A vintage model traction engine restoration part 4, refitting the crankshaft and testing the water pump. It's a bit more than that, but I couldn't fit all the lettering on the screen. I need to remove these hideous studs. I mean, who could do a job like this? First though, I'm going to work on the bearing top caps. I'm rubbing them on a piece of wet to dry sandpaper to make sure the bottom part of them is flat. And now I can wait no longer. I have to get rid of these studs. I'm using my Barco wrench for this. This is a pipe wrench and it's quite brutal, and yes, it does mark the work. I would only use it for something that I'm going to throw straight in the bin. The good thing is it really grips tight, and in no time at all both of the studs are removed. This will not be very good for the flywheel side though, because there isn't any room to get the tool in place. One of the first things I'm going to do is scrape the paint off the top surface, and also I'm going to rethread the holes. This is a 4BA tap, and I'm going deep into the hole as far as I can get through it. By doing this, I'll be able to screw the new studs further down into the main block. I'm taking great care to follow the original thread. I don't want to cut a cross-threaded version. These were 4BA to start with as far as I can tell, but the purpose of this exercise is to cut the thread a lot deeper, and as you can see, there's a lot of material coming out of the hole at the bottom. And before anybody writes in about why don't you cover things up to get rid of the swarf, there's no point. I can just blast it away when I'm ready. This side is going to be more difficult because there's less room to manoeuvre. I fitted a couple of 4BA nuts onto the studs, and after I locked them together with a socket and a spanner, I could easily remove the studs. This is the main bearing from the right hand side, and so I don't get mixed up, I've put a letter R on the inside of the bearing using a felt tip pen. The bearing cap that I took from this side was in mint condition, mainly due to the only part of it ever touching the crankshaft was the shiny bit. On both of these bearing top caps, the oil holes were blocked. Time for a bit of a clean-up. The end of this crankshaft is a bit rusty, so I'll keep attacking it with a piece of Scotch-Brite and eventually it will start to shine. Now the crankshaft is free, I can remove the connecting rod. And also, while the crankshaft was in this position, I could get a spanner right underneath to tighten up the leaking pressure gauge unit. The first part to be removed is the crosshead pin, and I do this by removing one of the nuts and pulling the pin out. And now I'm able to slide the connecting rod out of the crosshead. Now to move on to the big end. The bearing is supported by a strap, quite similar to my large traction engine, which has a nut that can be tightened to pull a steel wedge tightly into a slot to hold the bearing in place. But on this traction engine, it's not a wedge-type cotter pin, it's just a bolt with a fancy head. Now I can remove the strap and the bearings to have a look at them. It was fitted with one of these, it's a shim. Here I'm checking the dimensions of the crank pin, and it doesn't appear to be very badly worn. I've been stalling on this part of the job, but I'd better get on with it. I don't know what these nuts are that were originally fitted, but they're totally wrong. They would not even lock together. It's the fitting metric parts to imperial parts. When you get to BA sizes, they're actually quite close. But not close enough. If it's a BA bolt, it needs a BA nut. BA stands for British Association. While everything's loose, it's a good time to give the crankshaft a clean with some Scotch-Brite. Here I'm cleaning the crank web. And once I'd cleaned up the crank web, I blasted it with some WD-40. Although when I look at the video clip, I realise I've missed some bits. In this clip, I'm re-tapping the holes with a 4BA tap, just like I did on the other side, and again, all the way through the casting. As I'm editing this video, I notice that the tap looks like it's going into a bit of an angle, but it isn't, it's the camera angle. In no time at all, and without breaking off the tap, the 4BA holes are tapped all the way through. In this clip, I'm using a screwdriver point to remove every bit of paint from the bearing seating. It would appear that the last person who worked on this engine did not consider that to be important. Refitting the top caps where the holes are blocked up isn't too smart either. These holes were so blocked I had to use a small drill to drill them out a little bit. And for the more meticulous viewers out there, I will blast away the swarf with some WD-40 and an airline before I finish the job. This refit of the bearing top caps is just temporary. I'm using some machine screws just to check the bearing fits. It's quicker than fitting the studs. This is encouraging. When I fit the oil cups with lubricating oil, it doesn't run straight through. It's time to rotate the crankshaft and see what it feels like. All I can say is it feels absolutely beautiful. No play anywhere, and it's completely true and completely smooth. Now it's time to refit the eccentric that drives the water pump. These 4BA nuts on the eccentric strap are far too big. So here, using a 4BA tap, I'm about to rethread some 5BA nuts. These look better, they're not as big and ugly. Just for a moment there, that last statement brought back some memories from my past, but I won't go into that. Instead, I'm going to thoroughly lubricate the water pump and test it to see if it works. As I rotate the crankshaft and the pump ram goes in and out, even though it's pumping air, there's nothing leaking from around the pump ram, and that's a good thing. Time to test it using some water. I've connected 2 pipes, one to the pump's inlet and one from the pump's outlet. And obviously the pipe going to the pump's inlet is submerged under the water. All I have to do now is rotate the crankshaft and see what happens. This is very encouraging. There's some oil coming out with the water because don't forget I lubricated the ram with oil. But the pump is pumping water. What I need to do now is nip the pipe and see what happens. I can feel some pressure, but not enough. I would think that the ball valves need attention on the pump anyway. I haven't looked into that. When I open this small tap on the end of the pump, water comes out of it. That's a good sign. And what's the purpose of this valve? It's a bleed valve. It allows water to be bled through into the pump itself. On the top of the pump's water chest is a blanking plug, and removing this allows access to the outlet ball valve. And similarly, there's a blanking plug underneath that allows access to the inlet ball valve. The blanking plug underneath is leaking, and not unsurprisingly, the small drain tap's leaking too. I'll look into the leaking pump issue in a future episode. It's not very important for the moment. I still have quite a long way to go with this job to make this traction engine run successfully. The videos are short, but over the 4 days I've been working on the engine, I've put in over 20 hours so far. That does not include making the videos, that's just me doing the job. You'll see the progress in detail if you continue watching the video series. Anyway, that's it for now. I'd just like to say, as always, stay safe and well. Thanks for watching, and I hope you found it useful. Please take the time to visit my Mainsteam Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.